So in this lecture, we see the topic cosets. So cosets are nothing but the sets. Let H is subgroup of group G and A belongs to G. Then the set of all HA such that H belongs to capital H is called right cosets of H by A in G. So here see that element A is on the right hand side of H. So for all H belongs to capital H, the set of all H into A is here fixed element. So this set we denote it by HA. So this is nothing but known as right cosets of H in given say group G. So thus HA is equal to set of all H into A such that H belongs to capital H. म्हणजे इथे आपण H च्या प्रत्येक एलिमेंटला राइट हँड साइडने A ने मल्टिप्लाय करतो. Similarly, we define the left cosets of H and H of G by AH. इथे H च्या प्रत्येक एलिमेंटला A ने मल्टिप्लाय करायचं लेफ्ट हँड साइडने. So this is the set of all A into H such that H belongs to capital H. So here we have H belongs to capital H. Now consider the examples. Let H is equal to set containing 1 minus 1 I minus I, the group under multiplication, and H is equal to set containing 1 and minus 1 be subgroup of G. We have to find all right cosets of H in G. So here we multiply elements of H by elements of G on the right hand side. Means म्हणजे इथे H च्या प्रत्येक एलिमेंटला एक तर तुम्हाला 1 ने मल्टिप्लाय करायचं आहे, नंतर मायनस 1 ने मल्टिप्लाय करायचं आहे, नंतर I ने मल्टिप्लाय करायचं आहे आणि शेवटी मायनस I ने मल्टिप्लाय करायचं आहे to find all distinct right cosets. So we have right cosets of H in G is given by HA is equal to set of all H into A such that H belongs to capital H for fixed element A belongs to G. So H1, so here we multiply elements of H by 1. So that is equal to set of all H into 1 such that H belongs to capital H. म्हणजे H मध्ये दोन एलिमेंट्स आहेत 1 आणि -1 त्याला 1 ने मल्टिप्लाय करायचं आहे. So that is equal to 1 into 1, -1 into 1. So it is equal to set containing 1 and -1 that is equal to H. Then we have H minus 1. So multiply elements of H by -1 from the right hand side. So we get 1 into -1 and -1 into -1 that is again set containing 1 -1. So it is again same set that is H. Then we have HI. H into I. So multiply elements of H by I. So it is HI for H belongs to capital H. So that is equal to 1 into I and -1 into I. So it contains I and minus I. So this is another distinct cosets. Then H into minus I. So H into minus I. So elements of H are multiplied by minus I from the right hand side. So that is equal to 1 into minus I and -1 into minus I. So again it contains two elements I and minus I. So thus here we get two distinct sets. That is this one is first one set containing 1 minus 1 and this one is second one set containing I minus I. So thus H1 this one and HI are here H1 is equal to H minus 1 and HI is same as that of H of minus I. So there are only two distinct right cosets of H in G. They are set containing 1 minus 1 and set containing I minus I. So note that here operation is multiplication. Then we have next example. G is nothing but set containing Z8 with operation addition modulo 8 and H is equal to set containing 0 bar 4 bar which is subgroup of given group G. Then we have to find all right cosets of H in given group G. So G is equal to set containing these 8 elements 0 bar 1 bar 2 bar up to 7 bar and with operation here addition modulo 8. Note that here operation is addition modulo 8 and H is equal to set containing 0 bar 4 bar. म्हणजे इथे H च्या प्रत्येक एलिमेंट मध्ये तुम्हाला G चा प्रत्येक एलिमेंट ऍड करायचा राइट हँड साइड मध्ये म्हणजे 0 बार 4 बार मध्ये तुम्हाला 0 बार 1 बार 2 बार 3 बार 4 बार 5 बार 6 बार 7 बार ऍड करायचे आहे. ऑपरेशन इज हियर addition modulo 8. So we have the right cosets of H in G is given by set of all H such that H belongs to capital H for A belongs to G. So first we multiply the given set by 0 bar. Multiply means here operation is addition modulo 8. So H 0 bar is nothing but H plus 0 bar modulo 8 operation. So here we add 0 bar in 0 bar and 4 bar. So 0 bar plus 0 bar and 4 bar plus 0 bar is nothing but set containing 0 bar 4 bar. So it is H itself. Then we have H1 bar. H1 bar means H plus 1 bar modulate operation means here 0 bar plus 1 bar and 4 bar plus 1 bar. So it is 1 bar and 5 bar. Then H2 bar means H plus 2 bar. Operation is addition modulo 8. So it is 0 bar plus 2 bar and 4 bar plus 2 bar. म्हणजे इथे प्रत्येक वेळेस काय करतोय आपण 0 bar आणि 4 bar मध्ये हा एलिमेंट ऍड करतोय. एक तर 0 bar 1 bar 2 bar 3 bar up to 7 bar ऍड करायचे म्हणजे आपल्याला इथे सेट मिळतोय 2 bar 6 bar. Then we have H 3 bar means here H plus 3 bar. So it is 0 bar plus 3 bar, 4 bar plus 3 bar. So it contains 3 bar, 7 bar. Then H 4 bar means here H plus 4 bar. So 0 bar plus 4 bar and 4 bar plus 4 bar. 4 bar plus 4 bar is 0 bar and 0 bar plus 4 bar is 4 bar. Modulate operation. So it is again set H. Then H 5 bar. So it is H plus 5 bar. So 0 bar plus 5 bar and 4 bar plus 5 bar. But we know that 0 plus 5 is 5 and 4 plus 5 is 9. But modulo 8 operation. So its value is 1 bar. So we get the set 1 bar and 5 bar. So it is same as that of H1 bar. Then we have H6 bar. So add 6 bar in elements of H. So here we have 0 bar plus 6 bar and 4 bar plus 6 bar. So 0 plus 6 is 6. 4 plus 6 is 10, but modulate it is 2. So we have this set that is 2 bar plus 2 bar comma 6 bar. Then H7 bar, that is H plus 7 bar. So it is 0 bar plus 7 bar and 4 bar plus 7 bar. So it is set containing 7 bar and 3 bar. So thus here we have 4 distinct right cosets of H in given group G. So all right cosets are set containing 0 bar, 4 bar, 1 bar, 5 bar, 2 bar, 6 bar and 3 bar, 7 bar. Note that here all the right cosets are distinct. They are all disjoint. Similarly, we have the next example. G is nothing but Z, that is set of integers, group of integers, and H is equal to 3Z. It is subgroup of given group G. So we have to find all right cosets of H in G. So here operation is addition. Note that operation is addition and subgroup is 3Z. म्हणजे 3Z मध्ये सर्व तीन ज्या पटीतल्या संख्या आहेत त्यात आपल्याला G चे एलिमेंट्स ऍड करायचे आहेत. So by definition, right cosets is HA as defined above. G is equal to set of all integers. H is nothing but set of all multiples of 3, that is 3Z. Then we have H plus 0. म्हणजे H च्या एलिमेंट मध्ये तुम्हाला 0 ऍड करायचा आहे म्हणजे आपल्याला परत H मिळेल. नंतर H च्या एलिमेंट मध्ये 1 ऍड केला तर आपल्याला ह्या प्रत्येक एलिमेंट मध्ये 1 ऍड करायचा म्हणजे -6 plus 1 -5 होतो, -3 plus 1 -2 होतो, 0 plus 1 is 1, 3 plus 1 is 4 and 6 plus 1 is 7 and so on. So this one is H plus 1. Then we have H plus 2. म्हणजे या सेट मध्ये तुम्हाला 2 ऍड करायचा आहे. The -6 plus 2 -4, -3 plus 2 -1, 0 plus 2 is 2, 3 plus 2 is 5 and so on. Then we have H plus 3. So here we add 3 in this set so that we get same set. Then we have H plus -1 because Z contains negative integers also. So here we add -1. जेव्हा आपण इथे -1 ऍड करतो तेव्हा -6 -1 तो -7 होईल, -3 -1 -4 होईल, नंतर हा -1 2 5 म्हणजे हा सेम सेट मिळतो आपल्याला. जो H plus 2 मिळाला होता तोच तुमचा H plus -1 झाला. नंतर H plus -2 म्हणजे आता आपण -2 जर ऍड केला तर आपल्याला सेम सेट मिळतोय H plus -1 झाला. सो इट इज सेम ॲज दॅट ऑफ H plus 1. आणि H plus -3 म्हणजे सेम सेट मिळतोय तुम्हाला H, कारण की -3 ऍड करतोय म्हणजे काय करतोय आपण सबट्रॅक्ट करतोय 3 प्रत्येक एलिमेंट मधून. सो वी गेट सेम सेट H. So all distinct sets are nothing but what? H, then H plus 1 and H plus 2. So thus there are 3 right cosets of H in G. So similarly we can find all right cosets of this subgroup H set containing 1 minus 1 I minus Y in the given group G that contains 8 elements: 1 minus 1 I minus I, J minus J, K minus K. We have to find here all left and right cosets of H in G under the operation multiplication. Left hand side left coset म्हणजे काय, जो एलिमेंट असेल तो लेफ्ट हँड साइडला असेल, लेफ्ट हँड साइडला, आणि राईट कोसेट म्हणजे काय, तो एलिमेंट H च्या राईट हँड साइडला असेल. Note that let H is subgroup of given group G and A and B belongs to G. Then we have set of all HA into B. For H belongs to capital H, we don't read by this notation, capital HA into B. And set of all A into BH, for H belongs to capital H, this set is we denoted by A into B into capital H. So we have next theorem. Let G is the subgroup of given group G. Prove that HE is equal to H, that is equal to EH. Then HA into B is equal to H into AB. A into BH is equal to AB into H. And whenever G is abelian group, then there is no difference between right coset and left coset. That is HA is equal to AH for all A belongs to G. So proof of this theorem. So we know that HE means here we multiply all elements of H by E. So it is equal to set of all H such that H belongs to capital H. आणि आपल्याला माहित आहे आयडेंटिटी एलिमेंट ने मल्टिप्लाय केल्यानंतर एलिमेंट चेंज होत नाही. सो H E is nothing but H. So it is equal to set of all H such that H belongs to capital H. So that is equal to H itself. Similarly, we can show EH is equal to H. So thus here we get the first result, that is HE is equal to H, that is equal to EH. Then for second result, take two elements A and B belongs to G. So whenever A and B belongs to G, we show these two sets are equal. So let X belongs to HA into B. So X belongs to HA into B if and only if X can be written as small h into A into B, or some H belongs to capital H. Now here we use that associative law. So this is if and only if X is equal to H into AB. પરંતુ H into AB means it is element of that HAB. So this is if and only if X belongs to HAB. So thus here, whenever X belongs to HAB, then X belongs to H into AB. So these two sets are equal. So therefore, HA into B is equal to HAB. Similarly, we can show A into BH is equal to ABH. Again, use that associative law to show A into BH is equal to AB into H. Then third one, let G is abelian group, means your operation is commutative and A belongs to G. So G is abelian and A belongs to G. Therefore, HA is equal to set of all HA such that H belongs to capital H, but given group is abelian. So HA we can write it as AH. So this is equal to set of all AH such that H belongs to capital H, because G is abelian group. परंतु AH म्हणजे काय? It is set of all A into capital H. So thus here we get HA is equal to AH. Then we have next theorem. Let H is subgroup of given group G. Then we have to prove A belongs to H if and only if HA is equal to H, and A belongs to H if and only if AH is equal to H. So this theorem is important. A belongs to H if and only if right coset HA is equal to H, and A belongs to H if and only if left coset AH is equal to H. So suppose that A belongs to H and we have to show HA is equal to H. So we show HA is subset of H. So let X belongs to HA. X belongs to HA, so it can be written as H into A. So X is equal to H into A for some H belongs to capital H. So we know that here A is element of H is element of H. So H into A is element of H, because H is subgroup. So X is element of H. So thus here we get whenever X is element of HA, we get X is element of H. So HA is subset of H. Now we show H is subset of HA. So let Y belongs to H. So whenever Y belongs to H, we write Y as equal to Y. That is equal to Y into identity element. आपल्याला इथे A पाहिजे राईट हँड साईडला, त्याच्यामुळे E आपण याप्रमाणे लिहिला A inverse into A. So that is equal to Y into A inverse A. So that is equal to Y A inverse into A. परंतु Y हा H चा एलिमेंट आहे, त्याच्यामुळे A सुद्धा H चा एलिमेंट आहे, त्याच्यामुळे H आणि A हे दोन्ही H चे एलिमेंट येतील. Y A inverse हा H चा एलिमेंट आला, त्याच्यामुळे this element belongs to H. So it is element of H into A. So thus Y belongs to HA. So when thus here whenever Y is element of H, then we get Y is element of HA. So therefore H is subset of HA. So therefore from equation 1 and 2 both sets are equal. So therefore we get H is equal to HA, or HA is equal to H. Now conversely, suppose that H is equal to HA. So whenever H is equal to HA, we have to show A belongs to H. So A is equal to EA belongs to HA, that is equal to H. So thus here A is element of H. Just simple. Similarly, we can prove that whenever A belongs to H, this is if and only if left coset AH is equal to H. Then again we have next very important theorem. So this one is important one. Let H is subgroup of given group G. Then prove that HA is equal to HB if and only if AB inverse belongs to H, for all AB belongs to G. And whenever AH is equal to BH, then this is if and only if B inverse A belongs to H, for all AB belongs to G. So proof of this one. So in direct part we suppose that two right cosets HA equal to HB. So here HA is equal to HB. Now we have to show AB inverse belongs to H. Now we write A as equal to EA, so that belongs to HA. But here HA is equal to HB, so this A belongs to HB. So therefore A belongs to HB as HA is equal to HB. Now A belongs to HB, so we write A as equal to elements of H into B. So therefore A can be written as H into B. Here B is element of capital B. Sorry. Here H is element of H. for some h belongs to capital H. So for some h belongs to capital H, we have this one. हा b इकडे घेऊन जा. हा b इकडे आल्यानंतर काय होऊन जाईल? b इन्व्हर्स होऊन जाईल. So therefore we have ab inverse is equal to, इकडे h शिल्लक राहील फक्त. So ab inverse is equal to h that belongs to capital H. So thus here we get, whenever h is equal to hb, then ab inverse belongs to capital H. Conversely, suppose that AB inverse belongs to H, and we have to show HA is equal to HB. So here we show HA is subset of HB and HB is subset of HA. So take X belongs to HA. X belongs to HA. We show X is also element of HB. Now X is element of HA, so X can be written as element of H into A. So X is equal to H into A for some H belongs to capital H. So from that we adjust here B inverse. इथे आपल्याला AB inverse belongs to H, त्याच्यामुळे ते B inverse adjust करावं लागेल. मग इथे आपण लिहू एच ला एच ए इंटू ई आणि हा ई ला लिहू बी इनवर्स इंटू बी. म्हणजे इथे हा बी इनवर्स इंटू बी लिहिला म्हणजे इथे आपल्याला हा ए बी इनवर्स मिळेल. सो दॅट इज इक्वल टू एच इंटू ए बी इनवर्स इंटू बी. परंतु एच हा एचचा एलिमेंट आहे, ए बी इनवर्स पण एचचा एलिमेंट आहे, म्हणजे हा टोटल एलिमेंट तुमचा एचचा झाला आणि एलिमेंट ऑफ एच इंटू बी, सो इट बिलॉंग्स टू एच बी. सो दस वेन एवर एक्स बिलॉंग्स टू एच ए, we get x belongs to hb. So therefore ha is subset of hb. Now we show hb is subset of ha. So let y belongs to hb. So whenever y is element of hb, y can be written as k into b for some k belongs to h. So we write this again here we have to adjust a inverse. So here we write this k b into e. E can be written as a inverse into a, म्हणजे इथे तुम्हाला बी ए इनवर्स मिळाला. आता बी ए इनवर्स म्हणजे आपल्याला माहिती आहे, इट इज बाय रिव्हर्सल ऑफ इनवर्सेस ऑफ प्रॉडक्ट. इट इज ए बी इनवर्स इनवर्स. बी ए इनवर्स वी राईट इट एज ए बी इनवर्स इनवर्स. म्हणजे आता ए बी इनवर्स हा एचचा एलिमेंट असल्यामुळे त्याचा इनवर्स पण एचचा एलिमेंट असेल. के हा एचचा एलिमेंट आहे, म्हणजे हा टोटल के इंटू ए बी इनवर्स इनवर्स इज एलिमेंट ऑफ एच, आणि हा ए म्हणजे हा एलिमेंट झाला एच इंटू एचा. म्हणजे वाय बिलॉंग्स टू एच बी इम्प्लाइज y belongs to HA. So thus we get HB is equal to HA. So thus from equation 1 we have HA is subset of HB and HB is subset of HA. So therefore both sets are equal. So thus here we have proved that HA is equal to HB if and only if AB inverse belongs to H. So this one is very important result. Similarly we can prove that AH is equal to BH if and only if B inverse A belongs to H for all A and B belongs to G. Now next we have result. Let H is subgroup of given group G. Then prove that any two right cosets they are either disjoint or identical. म्हणजे आपण आधीच बघितलं की कोणतेही दोन राईट कोसेट एकदा इक्वल असतील किंवा ते डिसजॉइंट असतील, त्यामध्ये एकही कॉमन एलिमेंट नसतो. त्याचप्रमाणे एनी टू लेफ्ट कोसेट्स आर दे आर आयडेंटिकल ऑर डिसजॉइंट. मग त्यासाठी आपण दोन राईट कोसेट्स घेऊ. लेट एच ए अँड एच बी बी एनी टू राईट कोसेट्स ऑफ एच इन जी. सपोज दॅट दे आर नॉट डिसजॉइंट, म्हणजे ते डिसजॉइंट नाही तर आपण सपोज करू that is their intersection contains at least one element, that is HA intersection HB is not equal to 5, म्हणजे त्यात कमीत कमी एक एलिमेंट असेल. So let x belongs to HA intersection HB. So x belongs to HA intersection HB means x belongs to HA and x belongs to HB. So therefore we can write x is equal to h1 into A and x is equal to h2 into B for some h1 and h2 belongs to capital H. Now let z belongs to HA be another element. So z belongs to HA is another element. We write z is equal to h into A for some h belongs to capital H. Now we write this a x as we know that x is equal to h1 into A. So we can replace this A by x into h1 inverse, or because x is equal to h1 into A. So from that we get value of A is equal to h1 inverse into x. So A is equal to h1 inverse x. So we put here, but x is equal to again h2b. इथे ही x ची व्हॅल्यू आपण पुट केली, x ची व्हॅल्यू आहे तुमची h2b, त्याच्यामुळे x ची व्हॅल्यू पुट केली आणि ही h इंटू h1 इनवर्स इंटू h2b याप्रमाणे. सो ऑल दिस थ्री आर एलिमेंट्स ऑफ h. हे सर्व h चे एलिमेंट झाले. हा h चे एलिमेंट झाला इंटू b, म्हणजे हा एलिमेंट झाला तुमचा h इंटू b चा. So thus whenever z belongs to HA, we get z belongs to HB. So therefore we have HA is subset of HB. Similarly we can show HB is subset of HA. So thus here HA is equal to HB. So thus if these two right cosets are not identical, then they are equal. So thus any two right cosets of H and G, they are either disjoint or identical. Similarly, we can show any two left cosets of either any two left cosets of H in G are either disjoint or identical. Okay.